Now can you see my screen?
Yeah, I can see now.
Okay, yeah. Tell me, what is this area under the VT graph for the object with the uniform acceleration? Explain me what is happening in this part now.
Okay, so like right now, from A, like the velocity is increasing up till the point B at time in the time graph, like the x-axis on point D, like until the point D in the x-axis. The velocity is increasing like from AB. Okay.
Correct.
Like, and they do these like things like these dotted lines to like I think it's for like easily measuring the area. Like first there's this rectangle and then there's this triangle.
Okay.
Like first we can like find out the area of this rectangle and then add it up with the area of the triangle.
Correct.
And that's all I think it is.
Yeah, no problem. So what is V0 here and what is V here?
V0 is initial velocity and V is final velocity.
Okay, absolutely correct. And why is V0 is above the origin? And
because the acceleration was already like starting, like I mean the velocity was already, the car was at, the thing was the object was at like the object was at a velocity before, like
correct,
even entering this graph. They didn't show it started from O, so
perfect. So object was basically having the initial velocity V0, right?
Yeah.
It was already in the motion. The object was already in the motion. That's why velocity was V0. Correct?
Yeah.
And since it is the uniform acceleration, what is uniform acceleration?
Like the uniform increase of speed, like
correct,
consistent increasing of speed.
Exactly, true. That means there is a change in velocity is constant.
Yeah.
Change in velocity is constant, so that acceleration is constant. Okay. So acceleration is not changing. Acceleration is constant, isn't it? Yeah. That means it has a fixed value of acceleration, which is a positive acceleration. That means the change in velocity is constant. Every instant of time there is a change in velocity. So change in velocity is constant, correct? So that's why you see. So between the time 0 to t, your velocity changed to v. V0, from V0 it changed to v. That means velocity is increasing only, isn't it?
Yeah.
Correct?
Yes, sir.
And we can easily find between from 0 to t, the change in velocity was v minus v0, isn't it? BC will give you the change in velocity, right?
Okay. Yeah.
Correct? Since it's the velocity time graph, so we can find out basically from the 0 to t how much distance the body covered now. So if we find out the area of this graph AOTB, then it will give you the total distance traveled. Correct now?
Yeah.
Understood this part?
Yes, sir.
Okay. Now we can easily find the acceleration also here, because see, if we can find the slope of this line, okay, from A to B.
Yeah.
What is slope of this line A to B? So see, slope is basically the vertical distance BC by AC. Vertical distance by horizontal distance will give you the slope, isn't it?
Okay.
So slope will give you this part. So if I just write it here, now if we just clearly see here, now the slope of the line AB, correct?
Yes, sir.
AB will be given as
BC
by AC, correct?
Yeah.
So but what is BC? BC is nothing but V minus V0, isn't it?
Yeah.
V minus V0, isn't it? Now the whole divide by what is AC? T minus 0, that is T only, correct?
Yeah.
Correct. And the slope of line, because since it's the velocity time graph, so remember that.
Wait, like AC is shouldn't it be like AC?
AC will be equal to
like
0 to T. AC is this one.
Okay.
AC is OD only.
Okay.
Because this distance and this distance is same only, right?
Yeah, I got it.
Correct, no? So on the x-axis there is distance is T only.
Okay.
So slope of this line AB will give you the acceleration. So A will be like this. So when you cross multiply, you get another equation. V is equal to V0 plus 80, correct?
Yeah.
This becomes the V0, okay? V0 plus 80. So you basically you get the the final velocity is equal to initial velocity plus acceleration and time, and now we can easily
So
find
this is like V is equal to U plus 80, that one.
yeah, correct. V is equal to U. So V0 is nothing but U only. That also you can take it U.
Yeah.
Correct, no? Clear?
Yeah, clear, sir.
Okay, and then when you find the total distance traveled between 0 to t, you find the area of this shaded region. The gray region plus the blue region will give you the total distance traveled, isn't it?
Okay, got it.
Then that
So
will
like
give you
for
the
the
distance
area,
also.
we can just use a normal like.
Normal. See, basically AC OD is a rectangle, right?
Yeah.
So V0 into T will give you this area, area of so the total distance, right?
Yeah.
Total distance will be given as area of AC DO plus area of triangle, right?
Yeah.
What is that?
ABC.
Correct?
Yeah.
Isn't it? So when you substitute it, you get the total distance traveled. So once you get, so basically you are getting the first equation here, V is equal to V0 plus 80. Then total distance equation also you will get S. And another equation, same from the distance equations we can get the, see there is another way where we can find out.
Okay.
So total distance can be divided into one rectangle and one triangle. So this can also be given as distance can be equal to area of trapezium also, right? This looks like a trapezium, no? AODB.
AOD. It looks like, wait, no, it doesn't.
See,
it looks like a trapezium but with one side gone.
Trapezium is always one side is parallel, right? See, this side is parallel to this side.
Oh yeah, I just thought of an isosceles trapezium.
No, it's a trapezium. AODB is a trapezium, isn't it?
Yeah.
So trapezium's formula is also different, right?
Yeah. I don't remember the formula.
AODB. So here we'll do that. You remember that half sum of parallel sides into height, correct?
Okay.
That will also give you the distance. So here also you get one more equation. Here also you get the two equations. So basically 3 kinematic equations you will get.
Yeah.
So V square minus U square is 2AS, and here you will get the S is equal to UT plus half AT square.
Okay. Got it.
Understood this part?
Yes, sir.
Clear?
Yes, sir. So yeah, I have like a doubt regarding the acceleration.
Tell me acceleration. What's the doubt?
Like now, if this graph was here, right, AB shows the increase in velocity or
Correct.
acceleration.
Yeah.
So if I want to depict, if I want to show negative acceleration on this graph, how do I do
Correct.
it?
You want to show the negative acceleration in the graphs. Fine, perfect.
Yeah.
So this is a positive acceleration, right? Slope, see, slope is anyway, slope will give you the positive. The slope is coming positive. Now if the same thing, velocity goes like this, if the velocity goes like this,
Yeah.
then this will be the negative acceleration, correct?
Oh, okay. And wait, won't it be backwards or something?
Nothing, it's not backwards. See, velocity is from V is decreasing to V0.
Oh, okay. I understood. Okay.
And again we will go forward, then velocity become equal to 0.
Okay.
Then from here it goes, when you go downward again this direction gets changed.
Ah, yes. Okay. You just the car was going forward.
Yeah, now it's going
decreasing, then it just goes in reverse.
correct.
Okay. Got it, sir.
Clear? Any questions, any
Yeah.
doubts?
No, sir.
Superb. Interesting.